First of all, welcome everyone for the demo session today. Myself, Azad, I'll be a trainer for this entire course. So I would like to talk a little bit about myself, post which I would open my forum for you guys to introduce yourself and probably put up your expectations on this course so that we understand better. All right. So first thing, can you all hear me clearly? Just give it a thumbs up or raise your hands if you may, please, so that I can move forward. All right. I see one. Okay, I'll take it as a yes. Thank you so much. So a little bit about me. I've been in association with Network Journey for about 3 years and more now, if I'm not wrong. And I have an industry experience of about eight and a half years now. So I've been training for about 4 years. So I am a network architect in one of the organization and training Network Journey for about 4 years. So with Palo Alto, I've been into training for about same 3.5 to 4 years of time now. So you can be rest assured about the topics that we are covering. You can leave it to me, and you can ask your questions at the end of the session if you may have any. All right, so that's enough about myself. I will now go ahead and open the forum for you people to talk. Probably I might not be able to take up everyone's voice, but probably we'll let about 3 to 4 people to talk about them and their experience and their expectation of this course, and we can dive right in. Yes, please go ahead. Whoever wants to. Okay, I see around 28 attendees apart from me. So anyone who would like to talk about your expectations, your experience, so we can get going from there.
Yeah, hello, can you guys hear me?
Yes, please.
Yeah, how you doing? My name is Jose. I'm a solutions architect working in a financial industry. My specialization has been primarily in network engineering, data center space, network automation. And what I look to get out of this course, because I haven't had heavy experience in firewall, so this is like a blessing. I can be able to, get exposure to 5 different vendors. But most important is get a foundation understanding of firewall. That's my expectation.
Okay. That gives me an idea what you're expecting out of this course. Thank you so much, Jose. So anyone else who would like to volunteer?
Hello, I'm Kadir here. I'm working in Big AP F5. Okay, just I haven't know more about Big AP F5. Okay, but I know a little bit about ASA and Fortigate gateway. But this Big AP F5, I'm looking forward to know about. So I hope you will cover something about Big AP F5 today.
All right, thank you so much. I'll let probably two more guys to volunteer and talk, and then we'll move right in. Okay, I'll take once, twice if anyone want to. All right. Let's get things going. Without wasting much time, I'm gonna share my screen, and you guys let me know if you can see them. So I'll just try to explain the agenda today after I share my screen, and we can take it from there. Okay, I hope you guys can see my screen.
Yeah, we can see it.
Okay, fine. So my plan of agenda for today is to talk about, so I know this would be very basic stuff, but this is for someone who have just gotten into security or firewalls. So I would like to talk a bit about, won't take much time, but I would just talk about firewalls in general, and I would talk about next generation firewall, or I would say legacy versus next generation firewall, right? And then we'll get into the hoods of Palo Alto. I will talk about Palo Alto's features, just whatever comes in top of my mind, which would be important for you people to know, just as a brief. Uh, of course, we will talk about them and probably demo them as we go along the course. And once we are done here, we will talk about Palo Alto's packet flow, which is very important. And once this is completed, for the final 15-20 minutes, I would like to walk you through the firewall lab in the sense I would like to walk you through the dashboard for the GUI and basic configuration. So that's all I have for today. Um, so let's get started.
Are you
So
covering anything about ADC?
not today. We are not talking about it today. It's just about giving you some leaving you with some expectations on how the course is going to look like. So I am going to go over the theories of all these topics, and I will end up finishing with the firewall uh, basic configuration lab and dashboard overview. And definitely on the JD stuff, I will definitely be talking to you later when I'm touching the topic in our course. That would be later on, but definitely not today. So for today's agenda, this would be the topics that I will go through.
Got it.
All right. Okay. I will try to place this somewhere here. Okay. So let's talk about firewalls in general. So when we say firewalls, it basically involves um, the word we say is security, and as the firewalls evolved, we are talking about advancements in security. So in that way, in that process, let's talk about the legacy firewalls first. When I talk about legacy firewalls, I'm just taking an example of our uh, old own ASAs, which are, I mean, we had firewalls even before that, but since I started working in the industry, ASAs were the firewalls I started working with, and then we evolved into next generation firewalls, which we're going to study in this course. So when we talk about legacy firewalls, the main thing that it does is, again, it is responsible for securing any device inside our corporate network um, to go out to internet, right? And most importantly, the inbound traffic from internet is also supposed to be secure. Any firewall you could take for the matter is going to do the same thing. So the major ask it's going to fulfill is the security that it provides while going out to internet and coming into your network, right? So we do have special features for each and every evolution of firewalls, but the main thing that it solves, main problem that it solves, is to secure them. The way that they do so is going to be making them stand out. And right now we are looking at the next generation firewalls, the evolution of next generation firewalls, or the start of next generation firewalls, basically is because of the downfall that we saw in the legacy devices. So what were the downfalls that I'm talking about here is the legacy firewalls cannot inspect more than a specific layer in the OSA model. So so by now we should be good with what are the 7 OSA layers here for us. So when I talk about OSA layers from top down, I am talking about application, presentation, session transport, network, data link, and physical, right? So did I miss something? Okay, I wrote physical on the same line. Okay, so these are the 7 layers of OSA model. So what does legacy firewalls do? In fact, it does routing. It is a layer 3 device. And on top of that, it does security. But what level of security? It's going to do only the inspection up to layer 4 level. So it's not going to inspect anything more than layers 4, which, as you might have already guessed, your legacy, the next generation firewall is capable of doing so. So your legacy firewalls uh, can probably, I can think of inspecting TCP or UDP level protocols and port numbers. So and one whole difference about legacy firewalls over your routers is statefulness of the firewall. So I will talk about statefulness. So if a firewall being stateful, what is it that it could do? And this statefulness is carried over from the legacy firewalls to the next generation firewalls also. So this is a feature that's there from the ASAs towards the evolution of our next generation firewalls. All right. So like I said, it is going to inspect up to layer 4, and it's not intelligent enough to identify your end applications, and it's not going to work on the application layer. Obviously, it's not going to identify your applications on what exact application that your user is supposed to use. It only is capable of inspecting up to layer 4, and it knows what is the protocol, what is the port number, and accordingly it can maintain the session table, and it's going to be statefully inspecting the firewall. So when I say stateful, I mentioned this word about 4 to 5 times right now inside 1-2 minutes. So let me try to explain what a statefulness means. So when I say stateful, as I said, your ASAs to next generation firewalls, everyone are capable of doing this stateful inspection. So when I talk about statefulness, I'll take an example of this PC. This PC connecting to your firewall. So that I'm just ignoring the layer 2s here, the switches that sits in between, and all those layer 3 switches or layer 2 switches. So I'm just ignoring them. I'm just taking an example of a PC going through the firewall for your internet access. All right. So in this example, if this PC wants to reach, for example, a server in internet, let's say it's YouTube, right? So when this happens, this PC is going to send out, after all the DNS stuffs that happened, this PC is going to send out a traffic requesting for a web page from YouTube. So that's basically a web traffic, right? It's going to be over 443, right? So when this happens, this firewall is sitting in between. Of course, that the traffic is supposed to be allowed by the firewall when it goes from the PC to your YouTube server. When that is done, when the firewall allows the traffic forward on your client to server connection, client to server direction, when the YouTube server returns back your web page to the user, this return traffic, since because your firewall already knows this session being generated by a PC towards the YouTube server, web server. And for the fact that this firewall has already identified this as a session and allocated a session number to it and collected some information as to what is the source IP, destination IP, what's the port numbers involved, and other information. So since it has this information of the forward traffic in the session table of the firewall, the reverse traffic is supposed to be allowed automatically. That's a set rule in the stateful inspection. So that's why we call our firewalls or any device being stateful. So even now, if you see, if you might have worked in AWS environments, you have a concept called security group, which is going to take care of your security on an instance level. The security group as well is going to do the same thing. It's stateful, and when you allow this traffic in one direction, and the return traffic is automatically allowed. Now, this is not true. In what case this is not true is if, for example, we have a server which initiates the traffic. So here in this case, my PC is initiating the traffic, and the return traffic is allowed. That is what you call it as a statefulness. But when you say that the same server that you're trying to access for some reason is sending a traffic to your network inside, so this is not going to be happening because the initiator is the other side. And this is possible when you have a flow open from your server to the PC, because this server is the one who is initiating the traffic in this case, and the PC is the one who's going to respond to the traffic. So you are supposed to allow the flow on the firewall from your server outside to your whatever PC or your internal server inside. So this direction of traffic is required to be allowed in this case because the initiator is different. Initiator is from outside, and always the statefulness works when you are allowing the traffic from the initiator to responder, and responder to initiator. Return traffic is automatically taken care. Okay, so that's exactly what statefulness is about. And let me get rid of this. I hope I'm clear here. If you have anything to stop me for, you can let me know at the end of the session, or in between. Let's probably have a couple of minutes to discuss on the topics covered so far. All right. So after the statefulness of the firewall, I would like to talk about the legacy firewalls. Okay, we have already spoken about it. The legacy firewalls are stateful, and the difference is that the legacy firewalls are capable of only inspecting up to layer 4. That is dealing with only port numbers and protocols. Whereas next generation firewalls, it's going to do more than that, along with what a legacy firewall could do. Okay, that brings us to the third topic here, which is features of the Palo Alto firewall. So let me get rid of this. So I can talk about a lot of features. Probably we will do each and every one of them later, but today I'm planning to discuss on some 5 to 6 or 4 to 5 features maybe, which are very important, that we will be covering up today in brief. And while we move forward, each and every feature of it would be covered in detail. Okay. So when I talk about Palo Alto's features, this firewall is like any next generation firewall. So you have a lot of competitors. Like I can mention, I have Fortigate. You have Cisco as a competitor. You call it as Firewall Threat Defense device. You have Checkpoint and Juniper, and challengers would be your Sonic Wall, and another other vendors I can mention down the line. So the immediate competitors are these 4 firewalls that I have mentioned. So any firewall that you can take, for example, is going to be capable of doing whatever I'm mentioning here, maybe in a different terminology that they can name them. Okay, so let's talk specifics to Palo Alto. So when I say next generation firewalls, the first thing that I will be talking about is the layer, OSI layer here. So when I compared with legacy, I said that OSI layer 4 is what your legacy firewalls can inspect up to, whereas here in next generation firewalls, it can inspect the application layer as well, in addition to layer 3 and layer 4. So what I mean by that is, I'm going to bring up a specific feature which is called application ID here. That explains me of what I'm trying to talk about here. So when I say application ID, I'm just taking an example for that here, the same example that we just spoke about for your stateful inspection. Your PC connected to your firewall, right? And you have your internet cloud here sitting right here. So when you have your PC going to internet through your firewall, presumably your Palo Alto, the firewall is capable of doing an inspection which is application in the application layer level, wherein if, for example, you are typing an URL in your web browser that says facebook.com, that's without saying it goes like it's an SSL traffic, right? It's an HTTPS. So when you are initially accessing a HTTPS traffic, may it be Facebook, Instagram, or anything, initially the traffic is identified to be SSL by the firewall. It doesn't stop there. It lets us do our work. We get into the page, we log in, and we chat with someone. We do a video call, and we send an image. So many things happen inside an application, right? So when you take an example of a Facebook, the firewall first identifies it to be an SSL traffic, and then it says, okay, I'm accessing something called Facebook, so it identifies the traffic to be Facebook first. And then when I get into chat with someone, it identifies the sub application to be Facebook chat. And if I'm doing a video, it's going to identify it to be Facebook video. So each and every sub application that the firewall can identify is going to be available for us in the traffic log to actually see what a user's end application is going to be. How does it all do that? Without getting into the discovery or the research on what's done behind, from the website of Palo Alto, we were told that it is going to utilize Palo Alto's application signatures, app signatures, with which it is going to identify the pattern of the traffic. For example, if it's HTTP or HTTPS traffic, it is going to be in HTML specific format. So likewise, any application that you're trying to access, its format is identified over the signatures of the application that the Palo Alto identifies it to be in, and that gives us the specific application that the user tries to access. So that is how much that we have in our Palo Alto's page to view. Rest goes with the researchers to advance this further and then identify what they can improve from here. So far we can identify any well-known application if we go through, if the traffic goes through the firewall. So that's about app ID. Okay, so that's one of the important features that I would like to talk about. And after this, probably I will talk about user ID. When I say user ID here, I am taking another example, the same one. When you are trying to access any traffic, wouldn't it be easy if you are integrating your Active Directory's user ID database, that is user to IP mapping database that you have in your domain controller, the AD. and the firewall utilizes it to identify which users the traffic is generated from, or for what from to which server the traffic is actually going to from internet. So for whatever reason, if you would like to identify who is choking your bandwidth of your internet, if it is happening, for so many reasons, you might need to know who the exact person is, and maybe which office he is sitting. So you would be able to achieve this by probably integrating your Active Directory, or wherever you have your user database in, you would be 100% able to integrate them onto your firewall. So there is a specific configuration you would need to do, and if your user information is locally configured, that's pretty easy for you to do. But mostly for an enterprise, you would have your Active Directory separately available in your data center, and you can connect to the Active Directory and pull in the information of your users and what IP he is currently using. So that can be utilized in a security policy, right? So in your security policy, you can probably mention which user is allowed for the specific traffic, and which user group is allowed for the specific traffic. Even you can integrate when you can pull in the groups of your Active Directory that you've created. You can allow or deny the traffic or control the traffic based on that. And even if you have left the rule open, let's say from corporate zone to untrust, you can allow HTTPS for everyone. Okay, so if that's done, even though you have not mentioned anything in the security policy regarding the user, you have not permitted anyone, you just left it open, like I said, now your traffic log is going to identify which user has done what. So you also have the feature of looking at this in the graphical representation, which you call it as application command center ACC, where all the information that you see as a log format can be visible for you, or can be available for you in graphical representation. So like, for example, I would probably show you this when we talk when we look at the lab um, topology, or when I'm going to demonstrate something on the lab. So this is about the graphical representation, and you can also view the same log in your log format in the monitor tab. Okay, so that's about the user ID. So this is going to let you understand which user is basically using what traffic, accessing what, downloading what, which file, and how much of data he's maybe using for your bandwidth to get choked, or if he is really the person that needs to be informed of his internet usage. Okay, so that's about user ID. The next feature I would probably talk about is a wildfire. We'll talk about one more feature after this, and then we can get right into the packet flow, right? Because packet flow is going to take about 20 to 30 minutes, and then we'll have to again do our lab. So yeah, so wildfire is something that is very useful, which probably we don't have to work much to configure anything there, but a proper strict wildfire policy is going to save a lot for the organization in terms of compromising your network, right? So you have your PC here, the same example, the same diagram I'm taking as an example. So when you have a PC and a firewall, and when this attacker sitting here on the internet is sending a traffic to your internal network through a phishing email maybe. So when this guy receives this phishing email, he clicks on that link, and he happens to download a file, and uh, it's probably an executable or whatever. If he's trying to open that file, consider that this PC is going to get compromised. Okay, so this specific type of a trend of attack that is sent from this guy attacker here to the PC. Let's say this firewall is noticing it, and for the time being, the threat licenses that it has or the wildfire licenses that it has is that these two haven't identified this traffic to be a threat so far. So far, the signatures that these two features has are not identifying this to be a threat because it's a zero-day attack. So that's what you call it as a zero-day attack, right? So it's a type of attack that wasn't seen before or identified before. Okay, so let's say this type of attack is not in the database of your threat or wildfire licenses. So in this situation, this PC gets compromised, which is not a good thing, but the firewall which notices all this is going to inform the same to a sandbox that sits in the Palo Alto's cloud in internet. So it's going to send this traffic to the sandbox computer here. And this guy is going to initiate the same traffic that your internal user did to the same server here or the attacker here. Or he's trying to maybe download the same file by clicking on the same phishing email, the link sent in the phishing email. So when this is happening, this PC will be able to identify whether this is indeed a threat or not. Again, the details of how it's done is not something that we would need to know or not been mentioned anywhere in the documentation. So this is going to identify whether this indeed is a legit threat that we need to be cautious on. So once this is identified to be a threat, it tags the sandbox tags this as with a threat ID. And the best part is it's going to send the information to this firewall to mark this as a threat, and we can take actions accordingly. Along with this information is going to be sent out to any device in the world all across the universe which is having a threat license or a wildfire license, right? So if for people who for enterprises who don't have this wildfire license but only the threat license, will get this information within 24 hours of time, a little later than the ones who has the wildfire license. The ones with the wildfire license is going to get it within 15 minutes, right? So it's only the time taken that varies. So for example, if I have the wildfire license, I'm going to get it within 15 minutes, maybe anywhere in the world I am. And if I have my threat license active, not the wildfire, I'm going to get it within 24 hours of the time since this has been identified. If we don't have both, we will not be knowing about that information or the specific threat being identified by the firewall. Okay, so that's about the wildfire, and obviously it's not going to happen automatically. After this has been identified to be a threat, we need to take care of configuring our security profiles, which takes care of our antivirus, anti-malware, and all those stuff properly to block these type of traffic, so that this makes some sense
என்ன
for
இது
us.
இப்படி ஒரு நாத்த வேலை பண்றேன்?
Guys, I would request to mute yourself if you don't have any questions related to our topic. Okay. All right. So wildfire is been done. We'll talk about how things are configured later on, but for now the concepts are something that I'm planning to introduce yourself into. Okay, so apart from this, maybe let's get into IDS and IPS features. So what exactly the firewall can offer in IDS and IPS features, wherein you could probably do antivirus inspection. Sorry, anti-spyware. It could do wildfire analysis. That's exactly what we spoke about just now. It can do file blocking. It can identify specific file extensions and if we choose to block them, it will be blocked by the firewall for whichever traffic we choose to block them, right? I'll just say file blocking. It can also block the traffic. It's again one of the feature that I can talk about. So the URL filtering is again a feature where your firewall is going to categorize your URLs based on categories. So if we can also go search for any URL if we would like to. Let me go to my browser and try to Google some so we have a website here. We can test a site and identify which category it belongs to. So I can say there's a news channel, and it says it's categorized to be a news channel, and the risk level is identified to be low risk. So it's going to give us the category, the risk level, what risk level it is in. So which means that as a firewall engineer, we will be able to filter the traffic based on all these information that it provides us. So for example, if I need to uh, allow the traffic which are of high risk, or not allow the traffic which are of high risk, allow the URLs which are of high risk. So I can say that I can filter the you can create a URL filtering profile and make sure the high risk URLs are blocked on that profile, and indeed assign that profile to your security policy. Okay, so all these profiles that we create, they are supposed to get into the policy that we are creating, and that's when it takes effect. Okay, so URL filtering is basically identifying the category, the risk, and the subcategory maybe of the URLs that we have, a bunch of URLs that the firewall identifies, and blocking them or allowing them according to our company's needs or policy. Maybe these risky URLs needs to be allowed for a specific team who are doing some pen testing, cybersecurity team. So those teams, they basically need them for their own testing purposes. So it's for the company's own security. They might do some testing for which they require some critical URLs to be allowed for their own network. So those exceptions can also be done. Okay. So these are the intrusion detection or prevention features that the firewall would offer. Um, so you basically create a profile and make sure what you allow or deny, or what traffic you're matching on that profile, and you allow or deny the traffic, or maybe show a warning to the user and then make sure that only if he accepts. So that's when we get a URL notification whether you need to continue to this website, because the company has identified this to be a website that is of some criticality. So we can give them an option to choose from whether or not to go with the website to view that content. Okay, so accordingly, you can create a profile and match it to the policy, and it would do its work from there. Okay, enough about the features. Let's get down to talking about the firewalls. Give me 1 second, guys.
Hi, I have one query here. Can I ask?
Yes, please go ahead.
Is it possible to block URL query string in URL filter option?
Uh, yeah, that is possible. What do you exactly mean? Can you please brief?
Query string, like if we are accessing PDFs, we'll get query string URLs. So is it possible to block by this URL filter option?
I mean, the part of the URL
Yeah,
query
that's
string, right?
correct.
Yeah, that is possible. You can use a wildcard to block them. So you can say that anything after, um,
Okay, contains like that.
yeah, it contains. Yeah, that is possible. Yeah, that's possible under URL category. So URL filtering profile is different, where you allow a block a specific category or risk feature. URL category is something that you have under objects tab of the Palo Alto firewall, where you can mention the URLs, and you can also say that there are specific wildcards that you can use. We can refer it under the Palo Alto's web page. Let me show you that.
Okay.
Okay, so this probably can help you. Yeah, so these are the examples that might help you here. So asterisk has some meaning, and this this symbol has some meaning. So basically, if you use a asterisk, anything that comes before or after is going to be covered. The slash
Okay.
will be allowing certain things. I don't have it in top of my mind, but this is going to help you, do that query string match.
Okay.
All right. Yeah, that is
Yeah, got
possible
it. Yeah.
under URL category.
Yep.
Okay, so let me take a picture that you have here. So I'm just going to list down the stages under packet flow of Palo Alto Firewall. So when I say packet flow, it's basically going to mean that what exactly happens when a packet enters the firewall on an ingress interface and exits out through the firewall on an egress interface. So the stages involve ingress stage, and the last stage would be egress stage. That defines how the traffic enters and it leaves the firewall, and what happens in each of these stages. So we'll talk about them. And we have the second stage would be slow path, or this can also be defined as a session setup stage. And you have fast path, you have content ID and app ID information being identified. So these are the 5 stages where your firewall uh, would decide what to do when the traffic enters, and between the time the traffic enters and leaves the firewall. So let's talk about each one of them. I'm just making use of this diagram, which is available in the Palo Alto's website. It's called as flow sequence in PANOS. Okay. So I'm talking about ingress stage now, as you see. So it's basically going to identify some information when the traffic is received on the ingress interface. So it's going to take the information about the layer 2, layer 3, and layer 4, which is your port numbers for layer 4 and IP addresses for layer 3 and the MAC address information. And since this is a zone-based firewall, it's also going to identify the interface and zone and the corresponding zone of the interface. So for now, who doesn't know what a zone is, just think that a zone is nothing but your name given to the interface. It's much more than that, but for now, just understand it this way, where your zone is nothing but your interface's name that you give it to the interface, right? So once these informations are identified, this specific information is basically for the type of traffic where your previous device that is connected to the firewall's ingress interface, if they send out the traffic more than what the firewall could receive, at this stage the firewall will is supposed to fragment the data for it to divide it into chunks and send it over the wire. Okay, so only if it's applicable, it's going to fragment the information, or else your fragmentation is not going to be necessary. Okay, so once this is done, it's going to check for the errors on each of the information that it has got. For example, in layer 2, it would check for CRC error. So likewise, it's going to check for the state of the information and all the stuff in your information of layer 2, layer 3, and layer 4 that it is identified. And if it identifies there is some error in it, in the traffic, it's going to discard it. If not, it's going to let it in for other processes to take place. The next stage is about firewall inspection. It's going to check whether the firewall is inspection applicable or not. So how does that identify this specific information? How does it come to a conclusion? Is we will be having a table here where you will see what is a packet type. We'll talk about it later on. Tap mode is basically for your monitoring purpose. You're going to just place the firewall out of the line of traffic and just monitor. You'll use a switch and do a span configuration on it, and you can just pull out all the traffic log from the line of the traffic into the firewall. So that's what you call it as tap mode. So you're going to place the firewall out of the line of traffic and configure the interface in tap mode and do this. So we'll talk about it, but for now, just we can focus on this specific information where comparing what your packet type is, whether it's a unicast, broadcast, or multicast, and with that of interface operational mode, the firewall is going to decide whether it's inspection applicable or not, whether traffic is applicable for inspection or it's going to just forward or drop. So for example, if I have to take an example of broadcast, if it's a broadcast and if it's a layer 3, so for any one of us who have enough experience in networking, we know that layer 3 doesn't do broadcast. So if it's an IP broadcast coming in as a layer 3 traffic, and it's going to be dropped, right? And wherein if it's a broadcast traffic of layer 2, it's going to be forwarded or flooded. It's not going to be inspected because we know that it's any form of ARP traffic, right? Or if you could just think about unicast IPv4 and layer 3 or layer 2, it is a valid traffic to be inspected. Okay, so likewise, when a traffic is compared with respect to packet type and interface operational mode, the firewall will come to a conclusion on whether or not to inspect the traffic or forward or drop or only forward or inspect and forward both. So this table would help you in identifying that. So if you ever come across a situation where you need to have this information, you can come to this page and look for this table. You will have all the possible combinations here. Okay, moving down. This is basically if you have a IPsec or an SSL VPN packet coming in, and you know that it is going to be encrypted. And for the firewall to analyze the inner layer header, the layer 3 header, it's going to decrypt the traffic and go over the process again. Okay, so this is again the same process that's going to go through after decrypting the tunnel. Okay, so once everything is done, you come down to the firewall session lookup. So in the session lookup stage, it's going to see the with the information it has identified here at the top, over here, the layer 3 layer 4 information. So with that information, it'll check if the session is already there on the firewalls. It's an old session, or it's it's an already seen session. So if that is the case, it's going to continue with the fast path. Else, it's going to come to the slow path of firewall session setup stage. If it's a new session, so considering it is a new traffic, fresh traffic which has not been seen before, at least which is not available in the firewall session table, it'll come down to firewall session setup stage or slow path. Over here, it's going to do some important things, collect some important information. First thing is about collecting your egress interface and your routing information on the forward lookup information. So it's going to see what is the egress interface or zone and do a routing lookup. So when it comes down, it's going to next check the NAT policy lookup. So for the traffic that we have, the IP address and destination source and destination IP address, it's going to see whether we have a NAT policy defined or not in our firewall. So whether we have a NAT policy configured or not. If we do, it again checks if it's a destination NAT. If it's a destination NAT, it's going to do a firewall egress interface or zone check again, which means, what I mean to say is it's going to do this lookup again if and only if the destination NAT traffic is identified for this specific source to destination IP address or 6 tuple. So why do we do this? So why are we actually going back to check the forwarding lookup again when we see the destination, the traffic is NATed for destination for this traffic? I'll for a minute take the whiteboard again to explain you this. So when we said that the routing lookup has already been done, but still when the destination traffic NAT is identified to be configured on this specific flow, we say that the lookup has to be done again. So there's a specific reason for this. So let's imagine that this user in internet wants to reach this server here. So when he does that, obviously the layer of protection for our we as administrator is towards this network, because anything after this is internet, so we are not cared about. We don't care about that. So when we are trying to protect this, and if the traffic is coming from internet towards our network, we're going to do a destination NAT, obviously, right? So when we do a destination NAT, the firewall behaves in a certain way that when you define a security policy for this specific traffic from outside to your server, let's say this specific zone is zone 1, this specific zone where the server is, and this zone towards the internet is zone number 2. Okay, so the source zone here is zone number 2, that is untrust, and the IP address is any because the traffic is coming from internet. Okay, and when you configure a policy, this will be a source zone, untrust, and your IP address will be any. When you configure a destination security policy for this specific scenario in this direction, the firewall is going to look for the destination zone as post NAT zone and the destination IP as pre NAT IP. So you obviously will, this user in internet, if he wants to access an internal resource, he will obviously hit a public IP, and that will be translated out to a private IP, which is the original IP of the server. So the security policy, especially the destination part of the security policy, the firewall expects it to be in pre-NAT IP and post-NAT zone format. The pre-NAT IP means before NAT what the IP address of the destination would be, which is the public IP. And post-NAT zone is what is the zone after the NAT happens, which is the original zone of the server's private IP. So this is a way that we are supposed to write a policy and the firewall expects it to be. So because we are seeing a change in zone here, the firewall is checking the routing table again to identify the egress interface. Okay, so that's the background behind this. So it's basically about how the firewall needs your security policy to behave in. So that's the reason why we do an NAT lookup, the routing lookup again after you see that the destination NAT is applicable for this traffic. Okay, so once this is done, this is just about a lookup stage where you're just taking care of what information. You're just collecting some information. You're just looking up for the information. You're not doing anything. You're not performing any changes onto the network here. You're not implementing or you're processing the NAT here, which is done in the next stage. You're just looking up for the information here. And security policy set lookup, it's just going to uh, club in all the information that we have currently, which is your source and destination IP, source and destination port number, application, not application. In fact, the application identification is the last stage that I spoke about. In fact, the second last stage. So because the identifying of application is not yet done, it's going to keep the application as any in this case, and we'll be looking up for the security policy. So considering the application as any, with all the information it has, source IP, destination IP, source port, destination port, source and destination zone. So all the 6 information have been identified in our early stages. With those 6 information, this firewall is going to keep the application as any here in this specific case and look up for the policy identification. If the policy is set to be allowed, it's going to move forward and create a session. If not, it's going to discard the traffic, right? And this completes your slow path. And comes this after creating the session here, the traffic comes down to here, this stage where your fast path actually starts. Over here, discard packet, it's nothing but it's going to discard the packet if the session is not in active state. What does this mean is when you talk about a TCP connection, your first traffic that you expect would be SYN, SYN-ACK and ACK. So if you probably for some reason you see a data directly coming in without a TCP session being formed, 3-way handshake being formed, that breaches the rule of active state in the TCP. So if any of such behavior is seen, the packet is immediately discarded. Okay, and it does the NAT here if applicable. So the NAT we have identified here in this slow path stage will be implemented here, right? One of the other feature that I didn't talk about is the SSL decryption. So any SSL traffic, for example, the Zoom meeting that we are attending here, or the WhatsApp that I've opened here, or the packet flow that I have opened here in the Palo Alto's web page, everything is SSL encrypted. So the firewall, if we have we are required to inspect any specific SSL traffic, we can create a policy and ask the firewall to inspect them, which means that the firewall will decrypt the traffic, see what's inside, analyze them, and re-encrypt and send it back to the server. So that's one of the feature that the firewall would offer. We'll see that in action later on. So for that, we need to make the firewall act as a proxy, so that the firewall will sit in between and handle one session from the client here and create another session and handle it with the server here. That's how it encrypts and decrypts and re-encrypts the traffic between these two. So it basically performs proxy server and proxy client at the same time. So for the server session that it forms, it's going to be a proxy client, and for the client session that it handles, it's going to be a proxy server. Okay. So it's basically going to see if the firewall inspection is applicable or not, which means if we have configured any policy for if not, it will go on to the application identification stage. If the application identified, it's going to come down to content inspection. So this content inspection and the application identification is going to happen parallelly. That's what you call it as SP3 architecture, single path parallel processing. So it's parallelly going to inspect the content and the application identification, which is going to be making our processing of data faster. Okay, considering we have not identified the application here, it's going to come down here. It'll check if it's we have configured any custom application for our own company. So the company might have a custom application defined with a custom port number. So we can probably configure that. It will check if there is anything as such. If not, it will go on to see the pattern-based application identification, which I spoke about as application ID earlier. So it's going to check the pattern of the application. It's going to identify the application finally. Once that is done, earlier, if you remember, we have done a security policy lookup with the application as any. Here, after identifying the application, it's going to check the security policy by looking up the rule base again. With the application identified now, it is going to let us know whether the traffic is indeed allowed or not. Okay, so it's going to say the traffic is allowed or not, and then it's going to come down to content inspection here. In the content inspection, it again does the just various things: protocol parsing, decoding. No, basically your antivirus or your DDoS protection. What they will do is it will basically scan the traffic for, I mean, scan the firewall or scan the interface for any IP sweep or port scans or port sweeps. Along with it, it also does something called as protocol parsing or decoding, where it can end up identifying a different application. Okay, it'll again check if the application has changed from the content inspection. So it'll know that after the security policy lookup is done, it comes down to check if the application has changed here after the content inspection. If so, it is going to detect the result from the inspection and apply the security profile action. So over here, earlier I mentioned about creating a security profile for your antivirus, anti-malware, file blocking profile, URL filtering profile, and all those profiles are analyzed, and accordingly your security profile action is taken. Meaning we would have done some, we would have mentioned some sort of action that we are supposed to do for the specific security profile. Along with that, along with identifying the application, it's also going to check this parallelly and come down to see if the SSL proxy encryption is enabled here. So if the encryption, SL decryption is enabled here, this is the place where it's going to re-encrypt the traffic for it to send it outward on the egress stage. Okay, so once the content inspection and app ID is done, and if the SSL traffic inspection is applicable for this traffic, if it is decrypted earlier, it is going to re-encrypt it here and come down to the egress stage, where it's going to see what is your next hop egress interface or zone, and also see whether there is a QoS policy applied for the egress interface. If so, it's going to take that policy and apply accordingly. And like we did the fragmentation earlier in the ingress stage, here, depending on what is the capacity of your other side of the device that you're going to send this traffic to, it can even fragment the data and send it back to them. Okay, that's done here. And one last thing is, if you remember, if we have identified the traffic to be a tunnel traffic, we would have decrypted the traffic on your first stage, ingress stage. If that's the case, we'll re-encrypt it. If you're seeing the tunnel traffic as your traffic as inspection, you're going to re-encrypt the traffic and follow the egress stage again and transfer the packet out. So this is basically what happens in your overall packet processing in your firewall, which probably takes less than a second, but these are the details of it on what exactly happens here. So basically the good part about Palo Alto is your content inspection and your application identification is going to take a lot of load on your firewall, because this is just looking up for some information. Only over here, the application ID and content inspection, the firewall is going to go out to the cloud and get the information about your content inspection signatures and application signatures. So the firewall CPU is going to take a toll if this specific processing is not managed properly. Palo Alto Firewall has managed them pretty well, so that they both can happen at the same time parallelly. Hence, the processing speed as well is going to be improved. We're going to get the results pretty quicker than any other firewall out there in the market. All right, so I'll take the questions after this demo. So I'm just quickly going to, so the lab is built on EVNG, and I've just prepared a simple lab where I'm just going to show you the basic dashboard overview and maybe some basic configuration on how a PC can access internet from inside to outside. So we have our PC here. I'm just going to configure an IP address in the gateway for this one with the DNS information. After which we will get down to the firewalls dashboard. So I'm going to keep your inside network to be 10.1.1.0/24 as simple as possible. I'll say 10.1.1.10 and your firewall's IP can be 10.1.1.1. Okay, I'm giving the gateway as our firewall, which we will be configuring in some time. And I'll take the DNS as 8.8 and the secondary. Okay. As soon as the firewall is able to reach internet, we'll be trying out some browsing from this PC. Until then, we'll forget about this and we'll get to the firewall's CLI. And I've already got an IP from the firewall. So basically, I'm trying to connect my management network, my own network of this PC to my management interface so that it gets an IP directly from my local network as my EVNG. And I'll be able to access it right from a PC, right from my browser here. So it's .68. .2468, and here we go. We have the access. So the initial username and password would be admin and admin for you. And once you are keying in that information, the password, you will be directed to change your password by the firewall itself. Since it's your first time login, you will have to do that. And after you get into the firewall and start working into it, you can probably use your TechAxe integration onto your firewall for your password management. So your old password is admin. I'm providing that, and I'm just keying in my new password, and I should enter them again to get it. Okay, so as my firewall logs in, I would like to talk a little bit about the tabs that you would see inside your firewall. So two of the 5 tabs that we'll be seeing is for monitoring, and 2 is for configuration, configuring your actual traffic that you're trying to protect, and 1 is for your firewall itself. So basically what I'm trying to talk about is, give me 1 second. Yeah. So this is the basic information about your PAN-OS version that you're currently running. We are running 10.x. So first is dashboard. It's a basic information about your firewall. These 2 tabs, ACC and monitor, is going to give you some logs of the real-time traffic, policies and objects, and network. So these 3 tabs are for configuring anything related to the firewall. So this is for policies, this is for objects, and this is for your routing and IPsec information if you're configuring a tunnel or interfaces, zones. So all those network related informations are here. And your device tab is basically for your firewall itself. The firewall as a device needs some configuration. For example, your management interface, if you want to take a backup of your firewall, it's down here, and your interface configuration is here, and your HA configuration for the firewall is here. If you want to import any certificates, it's here. So let's talk about each and every one of them. Okay, so let's talk about the dashboard of the firewall first. So it's going to give you the basic information about the device itself, like general information like your device name, your IP address gateway, your model number of the firewall. If it's a VM, it's going to say it's a VM. Obviously, a real-time device will have a serial number, and what's your licenses for license information of each and every feature that you have. So this is the application version, the app ID version that you're currently running. So if you have a proper app ID license, and if you schedule your app ID version download, for example, if you don't schedule it to be every day at around 12 a.m., your application version, app ID version will be updated, provided your firewall should be able to reach internet. Okay, this is one of the examples. So likewise, you have threat version, you have URL filtering version. So so if you are paid, if you comes with a version that you upgrade the firewall to. Okay, so this is a basic in general information about the firewall. This is a logged in admins. I have logged in only through the web, so I don't have a CLI connection. So I'm the only person logged in. So it just shows my username. System log. There is another specific tab for the same under your monitor tab. System log is basically going to let you know what is happening on the firewall. So it's not going to let you know anything related to the real-time traffic. Okay, so it's not going to tell you which user is accessing what, and so on and so forth. If anything is happening on the firewall, for the firewall, that's going to be there on the system logs. For example, I have logged in now and I have changed my password now. Okay, you could see that over here somewhere. So authentication for the user from this IP address, logged in via web on this IP address, password changed for user admin, and then again I have logged into the web browser, web GUI. So all the information regarding, for example, if you set up a monitoring for your route, that is going to be displayed here. If your monitoring is down, that's going to be available here as an information. If your IPsec is down, that's going to be available here as information. So anything that is available, no, anything that is configured on the firewall, and if there is a change in that specific information, you can see them here. Anything regarding routing, VPN, authentication, so all those stuffs happening on the firewall is going to be on the system logs. Okay, so the last thing is system resources. This will give you your management CPU and data plane CPU and the session count. So right now, nothing going on the data plane, nothing is configured on your data interfaces. I'm using some management traffic for accessing the firewall and doing something here. So your management CPU, it shouldn't be 42, but yeah. So that's about your dashboard. So ACC, as I already mentioned, I am not a big fan of ACC until and unless I need to, provide some reports to my manager, who would like it in, graphical representation. So I'll just take one example under network activity to show you what it is. Okay, so let's take source IP activity as an example. So if you say source IP activity, any source IP address, how many bytes of data that IP has used or consumed, how many sessions, and if there is any threats involved in it, and what is the content information he has accessed, and which URL he has accessed, if at all it's a web traffic. So likewise, for each and every parameter, this is example that I'm showing you for source IP activity. Application usage, if you could say which application is used for how many bytes and how many sessions, and if there is any threatful application being used, if there is any threat identified on that specific traffic, for any specific parameter, the same type of checklist will be prepared, and you'll be having a graphical representation for that specific parameter, and based on the regions as well. So if you would like to report, prepare this as a report, here is where you need to be at. Monitor tab, it's again the go-to information or go-to tab for me to troubleshoot anything. Of course, you have your CLI, but the first point of contact for you to, first place where you come and look at any information is here. So as I said, you have system logs here, exactly what we saw in our dashboard. You see, I have accessed my monitor tab and I've logged in via web. I've changed my password. All those things will be available here, and also the severity. If anything is down, for example, if an IPsec tunnel goes down, that's going to be a critical severity event. Okay, so these are all informational events. So it's in green, and it's probably shows you what level of criticality that the message is going to give you. Okay, so you can filter with any of them. For example, if I need to filter with authentication success, I just click on that and I can just edit them to whatever I want. I can say authentication failure and hit enter. There is no event ID that is equal to auth failure, so it's not letting me in. So likewise, you can filter with anything that you want to. So I usually filter with description. So I can say description contains, and I'll just filter with anything that I know that it is relevant to be filtered with. Okay, so that's your system logs. Just show you some important uh, tabs that we can come across here. Session browser. So I told you about the firewall maintaining a session table. This is where you could see that. It could probably give you some information about what time the session has started, the zones, IP addresses, port numbers, protocol application rule, and you can even edit your columns. So many of them are not, so many of them are selected and few of them have not been. So if you need them to be available on your column here, you can do so by adding them. Okay, so right now there is nothing happening, so no session browser. It's basically a data traffic that we are looking at here. So nothing happening on the data planes perspective, so no logs here. Now you want to generate any reports, that's over here. And if you go up, you have all the logs that I mentioned, URL filtering, threat, wildfire. So all the separate logs that you can look at here. Decryption, okay, tunnel inspection, and traffic log is my go-to tab for me to first initially check anything that I need to check for troubleshooting. Okay, this will probably give me the first view of what is happening on the specific traffic that I'm looking at. Okay, so the next thing is policy. As the name explains, you have different types of policies that you can configure here. First is security NAT QoS policy, policy-based forwarding. So this is basically to overrule your routing table. So it's basically to say that don't look at the routing table before looking at me. So before even checking the routing table, the firewall is going to check this one for making any routing decisions. Okay, that's policy-based forwarding. And the decryption policy. So for SSL and SSH decryption, you come here and configure a policy. And likewise, application override, as I said, if you want to define any custom application, this is where you come and configure them. So this is your policies tab. And here is some optimizer where you can filter rules which are unused for 30 days, which are not used at all from the time is configured. So all those are available here. So in the objects tab, it's about creating your address objects groups, application objects and groups, services, tags, and if you come down, here is your profiles and that I mentioned about with regards to IDs and IPs. Okay, so apart from that, you don't have much to see here. Yeah, so if you grow global product information, that's a VPN solution here with Palo Alto. Network tab, as I already mentioned, you get to configure your interfaces, zones, VLANs, virtual wires. I'll come to that. Don't have to worry about it. Virtual routers is again your. I'm just explaining this because we're going to configure a basic setup for your PCs to access internet. So virtual router is nothing but your routing table. So it's basically when you consider a Cisco router, you configure without configuring any routing instance, it's already there for you, right? So likewise, without configuring any routing instance, you have a routing instance, your VRF configured default for your by your firewall. So if for your Cisco router, if you would like to configure any additional VRF, you create them. But for default VRF, you don't have to because it's already there. Likewise, for your firewall, your default routing instance or a VRF is already available, where if you want, you can use it for all your routing needs. But if you'd like to separate your specific interfaces from to that of others, you can create another instance of routing table. And like I mentioned, IPsec information, DNS, DHCP. Down here you have IPsec, IKE, all the configurations, interface management. We'll talk about that in a minute when we configure. That's pretty much about the network tab. Device tab, we've already seen just before starting the overview. Anything regarding the firewall specific configuration comes down here. For example, configuring administrators, assigning them roles. So if I'm configuring any user who wants only to, no, whose job is only to monitor, I'll just say that for him, I just need this monitor tab to be available. None of the tabs should be visible for him. So I can do so by configuring something on the admin roles here. And then certificates related stuff are configured here. And the server profiles, if you want to configure or integrate your TechAx information or TechAx or Radius onto your firewall, this is where you do it, or any authentication method for that matter. Okay, so here, down here, it's all related to your license updates or your software upgrades. So if you go to software, right now I don't have device certificate to give me the information I want. But basically, if you enable your device certificate of the file for the firewall, and if you have internet connection onto the firewall, if you get to this tab and you click check now, you will be provided with all your firewall software versions, from which you can choose one to upgrade the firewall to. All right, so that's about the overview. I'll take a minute to come back to the PC and just cross verify if I've configured what I require for this PC. I just need an IP address and DNS IP and the gateway for this. So I'll just verify that. So I have my DNS, I have my gateway 10.1 and my IP 10.10. Okay, so let's leave this here. And so accessing the CLI, configuring a management interface, bootstrapping a firewall. So all those stuffs will be discussed on our first session next week. So you can leave it to me. I will just focus on the GUI to configure your firewall to let this PC access internet. All right. So let's pull this down. And okay, so let's first finish configuring our interfaces. So I'm just going to make it simple, keep it simple, where I'm just going to connect this outside interface to my local network again, from where I can let it reach the internet directly. So which means I'm going to make this interface a DHCP, and like I did for my management network or management interface. So this interface is supposed to be configured to 10.1.1.1, like I did for my internal machine. So let's get to it. Your inside interface is 1/1 and outside is 1/2, right? So I'll go to my inside interface. I'll click on that under, let me tell you, under network interfaces. I go to my interface Ethernet 1/1 and I first decide what is my interface type. So there are types like tap interface. I told you what it is. HA interface. We will discuss them later. A virtual wire again. So there is layer 3 here. So I just need to configure an IP to this interface. So I choose layer 3 and I need to choose my virtual router, and I'm going to use my default virtual router available. And security zone. I told you about security zone, that they are just a name given to the interface, and it does much more than that. But for now, I am just going to configure two security zones, one for inside and one for outside internet. So I'm going to configure them later, just because I want to show you where it is exactly done, instead of configuring it right here. The IP address is 10.1.1.1 and the mask is 24. It's done. And we need to go and do one more thing here to the interface, which is configuring a management profile. I'll also keep that for later. I'll just click OK here. So I'll go down to configure a zone. I'll say it's inside. and I'll say that the type of the zone is layer 3 zone, and I'm going to add this interface Ethernet 1/1. So I can do it both ways. I can add the zone to the interface or interface to the zone. Both are going to be the same. Okay, so so this is like adding a interface to a zone. While I'm configuring a zone, I'm just going to add the interface that's available. So I'll show you the other way around, where I'm just going to configure the outside zone here and make it a layer 3 and click OK. I'm not assigning any interfaces now because I have not configured one for outside. So let's do that. So I'll say it's layer 3. Okay, so virtual router is default, and here is where you need to choose your zone. So zone is already configured. I'm just going to add the zone to the interface. And as I said, the outside interface is going to be DHCP client. And I need to mention my management profile also here. I'll click OK. Let's get to configure the management profile now. So it's nothing but on your normal router, when you connect a PC like this directly to your firewall or a router, when you configure the IPs, it's going to take care of the connectivity because it's directly connected. But in your firewall, you need to say whether this interface is enabled for ping. That's your management interface basically. You got to say which protocol is enabled for this interface, so that even though the routing reachability is there, only if your interface is enabled for that protocol on your management profile, it's going to let you access that interface on any protocol for that matter. So when I say management interface management, I'm just going to create one. I'll just secure, and I'll just enable HTTPS ping and maybe SSH. And I can also permit the set of IPs or networks I want this profile to be reachable on. And that's again another level of security I can give, but I'm clicking OK for now. And I'm just going to apply this to the interface. So first for the inside interface. So it's not a good practice to enable HTTPS, SSH, and SSL for your outside interface. But for the demonstration, it's gonna be okay for us. So here's just telling us that I'm just assigning the management interface profile here to the interface, and we are potentially exposing the firewall's administrative control. So I'm just saying okay. And over here, as I said, it's not a best practice to enable and keep the access open for the outside interface. But for now, let's just do it. And I'm just going to show you one more thing here. So let's see. Since I chosen DHCP here, I have an option that's already enabled where your default route pointing to the gateway is already taken care. There is no need of routing to be configured for us in this case, because since it's a DHCP client, the outside interface is a DHCP client. I am taking care that the firewall takes care of the routing for us. That's what this line says here. Okay, let's click OK. And let's go to the policy and create a security policy for me to reach internet from my inside PC. So this is my name I'm giving to the policy and the description. There are a few other things that you need to that you can do by you can probably give a tag for your description purpose. So for now, I'm just leaving it as defaults. So I need to say I'm going from inside, and source address I can define a network, or I can leave it as any. Let's define a network. So I'm just going to create inside network 10.1.1.0/24. Okay, done. And I'm not taking care of any users here. I'm just leaving it as any, and destination will be outside, and it's going to be for internet. So I'm just leaving it blank. I'm just not doing anything with the application or service. keeping it as any, and I'm clicking on OK. So that's it. That takes care of the policy. And the NAT policy again for our internal users to NAT to the probably the interface IP. So I'll say it's internet access, and the original traffic is from inside to outside, and the destination interface it can be any. I'm just taking care of my inside network as a source address, and destination is any for internet. And here I'm doing the source NAT, which is going to be PAT dynamic IP and port, and it's going to be for my interface address, and the interface is 1/2. If it's going to be static IP for your outside interface, you are okay to choose this IP, but right now, since it's going to be dynamic IP, it is subject to change. So it is good to keep them as none. In fact, the firewall will not let you choose any IP address. It's not going to be available in the dropdown. So for your dynamic IP address, your IP address cannot be chosen in NAT because it's subject to change. If your firewall reboots, you may not get the same IP. So that's the reason we don't choose the IP address. That's the interface. That takes care of our NAT policy. So I'm just going to commit this. So in Palo Alto Firewall, without committing the change, your changes will not take effect. It's not like a Cisco router where you configure an interface and the interface is configured and done. You know, if you save it or not doesn't matter. It do matters when a router reboots, it's going to lose the configuration. But for the time being, at that point of time when you configure them, the firewall is going to take effect. But in this Palo Alto firewall, your configs has to be committed, without which this configuration, whatever we did is going to be invalid. Okay, so here you have commit all changes and commit changes made by my administrator. So always choose this, because in case if any of your team members are doing any changes on the firewall at the same time, if you choose this and commit, their incomplete changes will also be committed, which is going to be a problem for you. Okay, always choose this one and give it some description if you'd like, and commit. So it's going to take a couple of minutes. Once this is done, my expectation is that this PC here, this warning symbol is going to go away. Maybe if it is not going away, I need to restart my internet Ethernet adapter, and it's going to go away from there. And once that is done, I'm going to get internet access for me to browse internet. So let's wait for my commit to be completed. So basically, whatever you do, it's going to be declared as a job here on your task manager. So your auto commit that the firewall did while you changed your password, that's the first activity on the firewall that's been logged here, and the commit that I'm doing is the second one. So once this is committed, I'm good to go check for my internet access on the firewall. So I'll just disable this guy and enable it once this is done. Okay, configuration committed successfully. So we are good to enable the network adapter now. So before that, I'm just going to go to the session browser, keep it active, and I'm just going to enable this adapter, and I should see this network up and running. Yeah, there you go. And I'm just going to give a try to ping youtube.com. Yeah, the DNS works, everything works, and we're good to go. So the reason why DNS works is because the DNS server that I'm pointing to is 8.8, and for us to reach the DNS server, it's going to be from inside to outside zone, because the server is in internet outside zone and we are in inside zone. So since I have not made any restrictions on the protocol and port numbers, the DNS traffic is also allowed on our single rule that we have configured for the policy. You see this? So my PC is trying to reach 8.8 for DNS, and it's picking up the same rule, and it's accessing them. So when I go back to browse something, that should go through as well. It's a bit slow today. Okay, so this gives us an idea that internet works, but let me get to okay, the SSL session is formed now, so again I'm good to go check the traffic logs, the session browser. So you see this, I'm accessing my web browser, but what do you see as an end application is your YouTube base. So that's exactly what I was talking about. Okay, so earlier when I accessed my Google web page, it's identified the application to be Google base, not SSL again. Here again, it is not identifying it as SSL, but your YouTube base application. So everything goes through my default rule that I've created because I have kept my application as open. All right. Okay. So I am leaving. I'm giving back some 15 minutes, but I think management would like to talk to you regarding the enrollment. I'll leave it to uh, I'll leave it to them, and post that I can take your questions if there is any. Sajid, are you there?
Yeah, I'm there. So you can have a Q&A and I will take the session.
Yeah, all right, Sajid. I'll be back in 5 minutes. You can take it over. Thank you. Would you like to take the like to take me the session with, or should I go with the Q&A first?
Yeah, you can go with the Q&A first and then I will take the session.
Okay, thank you. So guys, I think we can continue. If anyone has any questions regarding anything, you can unmute yourself and ask, and we can wind it up for from my side after that, and Sajid will take over from there. Any questions, anyone? All good, guys? Anyone has any questions?
Okay. What is
Yes,
the
Katirvel.
what is the difference between legacy and next generation firewall? Could you please a little bit brief about it?
Kadirvel, I think you have joined a little late, if I'm not wrong. I think that was the first topic we have discussed today. So in one line, if I have to tell, probably if you would have joined late, you might have missed that. So next generation firewall, sorry, legacy firewall is basically going to inspect, depending upon which firewall you're talking about as a legacy firewall. I'm taking ASA as an example. It's going to inspect only up to layer 4, which is a transport layer. When I say inspect, it's going to statefully inspect, which means that if the client to server traffic is allowed on the firewall, the server to client response is allowed by default. That's what we call it as a statefulness. So your firewall, which is a legacy firewall, for example, an ASA, it is capable of inspecting only up to layer 4. Like we just saw, this next generation firewall is able to inspect up to layer 7. That is the reason why it's identifying your YouTube application, even though you're accessing them over web. So over web, it's always SSL for any traffic, but depending upon the pattern, it has the intelligence to identify whether it's a YouTube application or whether it's a Facebook application or any application for that matter. So this is one difference, as I have explained you in the first half of the session. Any feature that I spoke about is not going to be there on your legacy firewall. So any feature that we saw with regards to wildfire or with regards to IDs and IPS features or application identification, URL filtering, nothing would be a feature available on your legacy. So
Okay.
yeah, so that's something that we spoke about in the initial first half of the session. Yeah, if you have missed it, you will definitely get the recordings from the management. You can take a look at it.
Thank you.
Yeah. Anyone else?
Azan, hi.
Yeah.
Uh, in the packet flow, when you were actually explaining, you showed us the complete workflow, right?
Mm-hmm.
So, in order to, understand that on a high level,
Mm-hmm.
is it okay to if we just could learn just the basic steps and not the entire workflow? I mean, suppose if for an interview, if anyone asks us like what will be the packet flow of Palo Alto and everything, so would we have to explain the entire set of the work, complete workflow, whatever you explained, or
Um,
the high level explanation would do?
yeah, it is basically going to depend on what the interviewer wants from you. But from my side, if I have to say, it is not practical to explain all of that, because
Exactly.
as you see, it's gonna easily take about 20 minutes or 25 minutes if you are explaining each and everything. But you can probably say that, according to how you can cook things up, you can say that it has 5 stages, and the stage one does basically about gathering some basic information, the 4 tuple information. Stage 2 is about creating a session wherein it checks for NAT and routing lookup. Stage 3 basically does SSL decryption, applying the NAT. So you can just cook things up in a couple of
Yeah, yeah.
sentences and mention them. If they want to ask specifically on anything, you can just give a disclaimer that, okay, I've just mentioned it in a short, considering time. So you can, if you want to ask anything specific, you can ask me and I can answer. So it's up
Yeah,
to the
yeah.
interviewer and how you explain, basically.
Got it, got it.
Okay. Uh, so anyone else before I hand it over to Sajid?
So thanks for the session.
Yeah, hi,
So
Panta.
I just wanted to ask if you're going to cover CLI part as well, because
Yes, definitely.
because
Uh,
I've seen so many Palo Alto working working on Palo Alto. They are comfortable with GUI, but not with CLI.
Indeed, I am also comfortable with GUI for the very reason that it is capable of doing anything and everything in GUI. But then, if for certain cases, um, certain things are not possible with GUI. For example, if you want to, there are certain cases where I have experienced your traffic logs would say that your traffic is matching on a specific rule, but actually it would match on a specific match on another rule, which you will be able to identify only in CLI. So there is a policy match that you could do, which you can do in CLI and check. And there are also certain troubleshooting packet captures that you could do from CLI only.
Okay.
So the like flow basic, there is something called flow basic, which is going to give you and the entire information of what happens for a specific traffic. So yeah, those sort of things, CLI is the one that you need.
Okay.
Yeah, I will show you topic by topic when we go over, We'll definitely start with GUI, but I'll also show you how things are done in CLI as well, meaning not the configuration, but how do you check logs in CLI? For example, if you're doing an IPsec VPN configuration, I would tell you how do you clear a tunnel using a CLI? How do you check for the logs for IK and IPsec using CLI? Those things which I am supposed to touch, which is important. I will definitely do so.
Yeah, but not related to like most of the configurations which we are normally do in like network, right?
No,
Like
it is not
IPsec
going
all
to
this
be,
stuff.
and it is not required according to me. No, it is not at all required. 90%, even if you get to the TAC engineer, the configuration would be done in CLI because that's pretty much understandable for anyone who sees the interface. Now, CLI, you need to remember the commands and you need to implement them, and it's not so user friendly.
Okay.
When you have an option of a user friendly interface, why to go for a tough one? So you will definitely, it's if you can give me a scenario on what cases you exactly want to do a CLI configuration, we can probably do that, because most of the time your GUI would be available. There is nowhere in my experience that I've seen that only CLI is available and not GUI, because in most of the cases your GUI will be available and you will be able to configure 100% of what you can configure in CLI. So in that way, considering that your GUI is comfortable enough for you to configure in terms of user experience, I always recommend to configure in GUI. But yeah, if you would like, maybe I can show you how an interface is configured. So a few things can be shown, but I would say it is not required for you to know each and everything in CLI.
Sure. Thank you.
All right, anyone else? Okay, I'll take it as a go ahead, and I'll let Sajid take over. Sajid, are you there?
Yeah, I'm there.
Okay, I am going to stop my sharing and you can take it over. And I'd like to thank you all guys for your patience, for staying in the session for about 2 hours. Sajid will let you know of further proceedings, and I hope to see you all in the next session. Thank you. Have a good day then. Bye bye.
Yeah, thanks, Azad. Bye.
Hello everyone. Myself Sajid. I'm the student relationship manager and the counselor. So I'm here to give you details regarding course enrollment and access and what all course will be designed. So actually end-to-end details I'll be giving you here. So can you please anyone confirm? Can you guys see my screen?
Yes, we are able to see.
Okay. So let me proceed with my first slide. So here you can see the course syllabus and class schedules. Okay. So basically this will be going to be a Firewall Mastery 5-in-1 combo. Okay. So here we will be going to cover 4 firewalls plus one load balancer. So basically we'll be starting from the Palo Alto. In Palo Alto we are going to cover PCNSA, PCNSE, and bit of panorama will be going to cover. Okay, and the next will be the Fortigate. In Fortigate, we are going to cover NSE 4 plus NSE 7. Both the papers will be covered here. And then next will be the Cisco ASA FTD, and like you can say Cisco ASA and Firepower. So then after that there will be the checkpoint, firewall, and at the end there will be the F5 LTM load balancer training will be there. Overall, for firewalls and plus one F5 LTM load balancer will be going to deliver the training on the Firewall Mastery 5-in-1 combo. Okay, and this will be the 5-in-1 bundle. So this course will be designed like this, and the class schedules. This will be going to be a weekend batch, Saturday, Sunday, every weekend, and will be from 7 p.m. IST to 9 p.m. IST, 2 hours of the session every Saturday and Sunday and every weekends. Okay, and the course duration will comes up for the 5 to 6 months you can consider. Okay, and if you count as standalone for the Palo Alto, so it will be going to take some around 2 months. So because here we'll be going to cover some more lengthy topics, so PCNSA, PCNSA and Panorama will be covered here. Okay, and let me move towards to the next slide. So here I'll be giving you the details regarding course enrollment and access materials, like what all access will be going to provide you. So firstly, you'll be getting the web portal access. So there you'll be getting the your class recording. So let's say you will be attending the class from the Zoom meetings. The recordings will be recorded from the backend and it will be uploaded to the our web portal. So that recording access and your web portal access will be remains with you for lifetime access. Let's say if you are practicing for any interview, sorry, if you are practicing for any interviews, if you are recalling the topics, or if you are like if you are just working on something and if you want to recall some topic or some module, so you can go through there and you can overview, and that will remain with you for lifetime access. Secondly, we'll be providing you the 24/7 backend lab access, so which are present on our servers and cloud servers, that you can access it totally remotely 24/7 unlimited. Whenever you want, you can access the labs. And for each firewall, so you'll be getting the 3 months of remote lab access. So let's say for Palo Alto, you'll be getting the 3 months of lab access. For Fortigate, 3 months of lab access you'll be getting, and for Checkpoint, 3 months of lab access. For Cisco ASA Firewall, you'll be getting the 3 months of lab access. And for F5 LTM load balancer, you'll be getting the 3 months of lab access, that you can access it totally remotely 24/7 unlimited. Whenever you want, you can access the labs. And we'll be providing you the dedicated materials like workbooks, PPTs, PDFs, step-by-step lab manuals. All the materials we will provide you, that you can download and you can keep it with you as well, and that will remain with you for lifetime access. Whenever you want, you can download from the G drive, so that will remain. And we'll be providing you the home lab setup. So let's say if you have the good configuration of your system, then we will help you out to set up a home lab, so that once you are done with your remote lab access, further you can practice on your personal laptop, on your personal system. Will be helping you out to set up a home lab. So the files you'll be downloading from the G drive, so we'll be providing you the instance to download. And after that, once you notify us, one of our team member will connect with you, and we will resolve do the setup on your system. And next, we'll be providing you the 24/7 backend support from our network journey team. Let's say if you are facing any issues, any queries regarding to the course, or regarding to the portal, or regarding to the labs, or regarding to the class modules, or anything it may be. So while practicing the labs, you are not able to move forward, you stuck somewhere. So in that case, you just need to raise a ticket on our support DL. One of our team member will connect with you, and we will resolve your issues accordingly in meantime. Okay, and this will be going to be your all access and materials will be delivered and given from our end. So